Okay. So, Assalamu alaikum, students. This is Cambridge Assessment International Education, IGCSE, Physics Paper 6 Alternative to Practical, February, March 2024. Let's start with question number 1. And this is the question where the student determines the mass of the meter ruler by balancing method. He is using an apparatus shown in the figure. This is the load, 0.0 centimeter mark. Then this is B. From the pivot point to the center of the load is marked as B. From this point, from the center of the ruler to this center of the load is A. This is the meter ruler. This is the bench. Now the student places a circular load on the meter ruler shown in the figure 1.2, which is not made to the scale. Now we have to determine the distance of the center of the load from the zero end of the ruler as shown in the figure. Figure 1.2 is not to the scale. Now, since we know that this is the circular center, and we have to calculate the distance B of the center of the load from the zero end of the ruler. So we know that we are going to calculate this by using the meter ruler, and we will use this. We know this is 26 and this is 30. So D will be 26 plus 30 divided by 2. The center of 26 and 30 will be calculated. So it is 56 divided by 2, which is 28 centimeter. Now this is D. Now we have calculated D. Moving on to B part of this question, in which they say that the student adjusts the position of the meter ruler on the pivot until the meter ruler is as near as possible to being balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. Okay, so you can see that the student is adjusting the position of the meter ruler on the pivot point. The pivot point is a very, it's a point where the gravity, the center of the gravity will be lying on it, and it would be balanced only if the position is exactly on the center of the gravity. The other thing is that the ruler can be moved back and forth to adjust the position so that it is balanced horizontally. And this can be confirmed by observing that the ruler tip to either side is exactly the same. Now, what we can do, we can write the technique here. Let's write the technique. We know that if we talk about clock, anti-clockwise and clockwise torque, that should be balanced so that it will be exactly at the point of the pivot and it will be balanced. So we can write the ruler can be moved back and forth slowly on the pivot, and until it is balanced. And we can say that, so as a result, we can say that clockwise and anti-clockwise torque momentum is balanced. And there is no turning effect on it. Okay, now moving on to the student finds that the ruler is as near as possible to being balanced when the pivot is at the 47.6 centimeter mark. Now we can move back and see that they are saying that the student is, making it the pivot point is exactly, they say that this point is actually 47.6. So this is the point which is 47.6 centimeter. Now, they say that calculate the distance A from the load, A of the center of the load from 50.0 centimeter mark as shown in the figure, and use your value of D from A. We have already taken A as 28, so we will be taking value of A as 28 and we will be putting it into the formula. So it's 50.0 minus 28. So it will be 50.0 minus 28.0. So it will be 2 and 2. So it will be 22 centimeter. Okay. Now we are going to calculate the distance B of this center of the load from the pivot as shown in the figure and use the value D again from the part A, which is 28. So now we will be taking this formula and the position of the pivot is at 47.6 centimeter as given minus 28. So I'm subtracting 47.6 minus 28.0. So it will be 6. So it will be 9.6 centimeter. That means, sorry, it's 19.6 centimeter. Now we are moving on to the next part where we will be talking about the graph. Now in this case, they say that the student moves the load so that its center is above the 5 centimeter mark and balances the meter ruler. He repeats this procedure for the load at 10 centimeter mark, 15 centimeter mark, 20.0 centimeter mark, and 25.0 centimeter. So his results are shown in the figure. Now we have to draw the graph basically. So here I'm going to just in case making the values visible and making the graph. Now they say that when you are making a graph, the graph should be like, in this case, they have told us that plotting the graph of A on y-axis. So A will be on y-axis, so making the y-axis here. So it will be like that. X and y-axis. Okay. So A will be on y-axis and B will be on x-axis. So writing the values, A as 45, 40, 35, 30, 25. So we will be taking as, and they say that you do not need to start your axis from the origin. So we are just going to draw the best fit line. Now it will be like here the value starting from, if we look at the position, it's like the minimum value is 25 and the maximum value is this one. So we will start it from maybe 20, 30, maybe like we can write 25, 30, 35, 40, and 45. We can take the values. Let's do it once again. The values will be, just a minute. I'm going to take the values in that matter. So it will be like if I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be like 20. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 30. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 40. And it will be like 50. Okay, this way. And then if we talk about B, which is on x-axis, so the minimum value is again from 22.5 and the maximum is 40. So the same way we will be taking 20, then 30, then 40, and then 50. Since I haven't taken the values exactly because my graph is not exactly on paper, so you need to do it by taking the proper 10 small boxes. Now, so the point is for the value on x-axis, which is 40.5. Now this 40.5 is 45. So I'm going to take from 40.5, the value is exactly 45. So this will be almost here. This will be the point. Okay, and then the value 35.2, which was like 35 is here and 35.2, the value is 40. So it will be exactly here. Then for 31.5, the value is 35. So the value is like here. Okay, and then for 26, this is the value. For 26, it's 30. So here we have almost here. And then for 22.5, the value is 25. So for 22, the value is like 25. So this is how. So we have to draw basically the best curve, best fit. So the graph will be made. If you make a proper graph, the graph will be a proper straight line. The best fit straight line. Okay. Now, because we have to determine the gradient and how you obtain the necessary gradient. So moving on to the graph back again, it will be my graph is like if I take it. Okay. So when we talk about the gradient, we can take any two values. Like maybe I can take the value. We have two different ways to draw the gradient. The gradient can be taken as rise over run. So this point and the maximum this point will be taken. We can draw this way. And the rise over run can be calculated by taking the value as from this point is like this point is 22.5 till this point is the maximum point is 40.5. So 40.5 minus 22.5. So I'm calculating the run as subtracting the value and looking at it that what is so the value is 40.5 minus 22.5 and the value is 18. And if I talk about a rise, it will be like this point is exactly the maximum point is 45 and the minimum point is 25. So I'm subtracting 45.0 minus 25.0 and I get 20. Now I get the rise and run, so I'm going to find out the gradient. And the gradient is rise over run. And then rise is 20 divided by run is 18. So it's 20 divided by 18, and it's almost 1.111. Now let's confirm our answer by using this marking key. Let's see what is the answer for this question number 1. So they say this is the part number. This is C part 1. So C part 1, the graph. And then if we see that appropriate scales, plot to all small and well-adjusted line. And then they say that G represent and use a triangle method on the graph. And we have done exactly that. Okay. Now they say to find out the value, calculate the mass of the meter ruler by using the equation K is equals to 25 over G minus. We have calculated the value of G as 1.11. So we will be plotting as M is equals to 25 over 1.11 minus 1. So let me subtract it first. 1.11 minus 1 is 0. So 25 over 0.111, and we will get, we have got the value 225.22. And since this is the mass of the meter ruler using this equation, so let's see the answer they have given, that M in the range of 100 to 400. So we have gotten this value exactly 225 grams, which is exact value which they have given us in the answer. Now the last part of this question is the accuracy of the result obtained by this procedure depends on the meter reading. Now they say without a load, balancing with the pivot at the 50 centimeter mark, a student finds that this does not happen. She adds a small piece of modeling clay to one end of the meter ruler to correct it. Now suggest if this is a suitable change for this experiment, explain your answer. Now we have to talk about it that they are actually talking about the suitability of modeling clay for correction. So addition of small piece of modeling clay to one end of the meter ruler is not a suitable change for this experiment. Basically, what they say in the answer key is exactly no. As the mass of the clay increases, the change of the mass of the meter ruler, or yes, the mass of clay only a small percent of mass of meter ruler, very little, or we can say almost no. If we talk about this one, so we can like say that no, as the mass of the clay increases, so we can write it here that no, the mass of the clay increases when if we increase the mass of the clay or changes the mass of the meter ruler. So it means in terms, as a result, mass of the meter ruler changes. So what we can say that the purpose of the experiment is to determine the mass of the meter ruler by using the given equation. So if we add the clay, basically what happens is like over here, if we say that by adding clay, the mass of the system is changed and the equation is no longer valid for the original meter ruler. So additionally, the center of the ruler is altered, making the calibration inaccurate, and the clay should not be used to correct the ruler. So we can write here that the clay should not be used, to correct the ruler. Instead, the experiment should be modified. Instead, the experiment should be modified to account for the imbalanced ruler, or a new ruler should be used. Or new ruler should be used. So the basic answer is basically no. The purpose is to determine the mass, so we can say is not a suitable change for this experiment. So the answer would be no. So this is all about question number 1. Stay tuned for question number 2 for the same paper. Thank you for watching my video. Do not forget to subscribe my channel.